So we're on steps, sketching of polynomial function. So these are the steps that we use in sketching the graph. So the first thing to do is to find the x-intercept. And how do you get the x-intercept? By substituting y equal to 0. That's the f of x, 0. We now find the values of x. Second step is to find the y-intercept. That is by substituting x equal to 0. The value of y is the y-intercept. The third one is to determine if the graph f crosses or touches the x-axis at each point. That's at each intercept. And how do you do this? Is by knowing the multiplicity. So we are going to do that. The fourth one is to check for the end behavior. Yes, it will help us to know how the graph will end. Very, very important. So the fifth one is to determine the maximum number of turning points. Yes, it will also guide us to know on how to graph the function. The sixth one is to use the s-intercept to find the interval on which the graph of f is above or below the axis. So we're going to use a table here because we've known the x-intercept, which are the zeros or the roots. We can now check between those. That's okay. We'll use a number. We'll still do it. As if you have the x-intercepts, those ones are on the x-axis, but between them something will happen. So it's either the graph is moving up, that is above the x-axis, or below that. So how do you do that? You just to pick a point between the two s-intercept, that's the roots. We are going to do that, and finally plot the points. So if you now plot from 1 to 6, that's our graph. So let's start. Assuming we are asked to sketch the following graph, this, and this. So we are starting with the first one. So we need to get the x-intercept. So the x-intercept means that y is 0. So that's the first step, the x-intercept. So we're going to substitute y equal to 0, which is hx. H of x is y. So we have 0 is equal to 1 over 2 times x minus 1 squared times x plus 1 squared. So what do you have to do? You know, for product to be 0 means one of them must be 0. So it's either x is 0, that's for the product to be 0, or x minus 1 squared is 0, or s plus 1 all squared is 0. So with that, you see that x will be 0, or x is 1, or x is minus 1. So these are now the x-intercepts. So to get the y-intercept means that we should substitute maybe let's y-intercept means that x is 0. So wherever you see x, call it 0. So again, we now substitute. We want to get the value of substituting s 0. So we have half 0, 0 minus 1 squared, 0 plus 1 squared. So we notice that we'll have 0. Because there is 0 here. So our y-intercept is 0. So it will touch y as it has 0. So the next step is to determine if the graph of f crosses or touches the x-axis. Okay. How do you know that it will cross or touch? So we use multiplicities to know. Multiplicity means the powers of the factor. So we have even multiplicity, and we have odd multiplicity. So that will help us to know if it will cross or if it will touch. So even means that it will touch. So even, it means that it will touch. So look at the powers. You see that it will touch at the even multiplicity as 1 and minus 1. So it will touch at this point at 1 minus 1, it won't cross. Why the odd one is it's 0. So it will cross at 0, but it will touch at minus 1 and 1. So the next step is check the end behavior. Okay. The end behavior, how do you know the end behavior? We need to know the degree. From here, we are on end behavior. So the degree of this n is the sum of the powers. So it's 1 plus 2 plus 2. So we have 5, and 5 is odd. So since it's odd, it will, so the graph will end like this. Let me get where we did something like that. Okay, look at this. You see, it's odd, so it will be, it's either it will be the last two, but from there you also see that the coefficient of the highest power, the coefficient, the constant there is positive, so the end behavior will be this. So I'm saying that that's the third one, the third graph. So see what I'm trying to say? I'm saying that since n is odd and an is greater than 0, that is positive. Our an is half. Are you seeing it? The coefficient is half. The coefficient of the highest power. So if you multiply, you see that half is the coefficient of the highest power here if you expand. So, and implies that the graph will end like this. Something like that. To end this way. So the next one is to determine the maximum number of turning points. Okay. Also, maximum number of turning points is gotten by the degree also. Is always n minus 1. So we have 5. 5 minus 1, 4. So the maximum turning point, how many times the graph will turn will be maximum. That's 4. 4 maximum. So we've gotten that. So the next one is to use the S-interval to find the interval. Okay, since we've known the intercept or the root, we're going to prepare a table to know how. See the table, we're going to fill in this. The roots, that's the x-intercept are minus 1, 0, and 1. So aside this minus 1, these are the points where it will touch or cross the x-axis. We still have numbers between minus 1 and 0, between 0 and 1, above 1, and below minus 1. So it will help us to know how the graph will go, whether it will go up or down, because at minus 1 it will touch or cross. At 0 it will touch or cross, or at 1 it will touch or cross. So we are going to prepare interval. So from x, we'll take some values, x less than minus 1, between minus 1 and 0, between 0 and 1, and above 1. So this will help us. Let's know the value of h. Remember, our h of x is half times x minus 1 squared times x plus 1 squared. So we're going to pick a point less than minus 1. So numbers less than minus 1, if you pick minus 2, when x is minus 2, let's see what will happen. We have, which is x equal to minus 2, I have h minus 2. So let's see what we'll get. This is 1/2 times minus 2 times minus 2 minus 1 is minus 3 all squared times minus 2 plus 1 is minus 1 all squared. So we'll see that we'll have this minus 1 times 9 times 1. So we'll have minus 9. So it will be below the x-axis. So this is negative. means that it will be below the x-axis. So let's test numbers. Let's test numbers between -1 and 0. So let's pick one. I think minus half. Yes, minus half. So let's use h as at x equal to minus half. So I have h of minus half is equal to half times minus half. Minus half minus 1 is minus half minus 1 is minus 1.5. That's minus 3/2 all squared. Minus half plus 1 is half, so half all squared. So what do you get? We get this is minus 1/4 times 9/4 times 1/4. So I get minus 9/64. So which is also between this is, that's the value is minus 9/64 and is negative. Yes, is negative. Let's check. This is 1/-1, or this is positive, this is positive. So it means that it must be below the x-axis. So between 0 and 1, let's pick. Let's wipe this. Let's wipe this. Let's test. Remember, h of x is half x minus 1 squared, x plus 1 squared. So let's test between numbers between 0 and 1, which is half. We have half times half. Half minus 1 is minus half, all squared. Half plus 1 is 3/2. That's 1.5. So which is equal to, this is 2 times 2, 4 times 2 is, okay, 16. So I have 1/16 times 9/4. So I have 9/64. So this is positive, and we have 9/64, and it's above since it's positive above. So let's test numbers greater than 1. So let's test x2. h of 2, that's I substitute x equal to 2, that's numbers greater than 1. I have 1/2 times 2 times 1 squared times 2 squared. So I have 4. Yes, this is 2, 1 times, so this is 4. This is positive and is above. So with this information, we can get our graph. Yes. So let's graph. So we are graphing. So let's label the axis x, that's y and x, the origin. So we're going to use everything we've done. The x-intercept, I think we got it as minus 0, minus 1, and 1. So I have minus 1, 0, and 1. These are the where it will either cross or touch. So using our multiplicity, so even multiplicity means that it will touch. So it will touch at 1 and minus 1, and it will cross at 0. It will cross as what? 0. So from here, it will cross here. It must cross, but it will touch at this. So it's either this or this, but we don't know for now. It will touch, it won't cross. It's either it goes this way or it goes that way, but for now we don't know. So let's now use extra information. But remember, from our end behavior, it seems it will end this way. See how it will end. Yes, it will end this like this. The arrow up and the other one. So what I will do, let's pick this point between. So we got when x is minus 2, we got minus 9 as y. When x is, this is minus 9, why this one is minus 0 point something. Either 0 point, it's not even 0.1 something. So let's put those values so that it will help us to. So when x is what? Minus 2. So let's put some value maybe here. When x is minus 2, y is what? Minus 9. So it went down. So far. So let's assume here is minus. Okay, let me just shift this. So I shifted it so that this is y. So when x is minus 2, y is minus 9. So let's assume here is minus 9. So this is one of the points. We've gotten 2 points now. At one extra point, this point, this. So, and between minus 1 and 0, I have minus 9 over 64 is minus 0 point something. So it will be very small compared to, so minus 0 point something when x is minus half. So if it's minus half here, it will be minus 0 point something somewhere here. Okay, maybe let me use another ink. Let me use white or yellow. So look at the extra point we got. These are the intercepts. So we've gotten extra points using when x is minus half. So which one again? When between 0 and 1, what did I get? Between 0 and 1, 9 over 4, which is positive, that's 0 point something. So almost the same length. So when x is somewhere here, half. So let me write this. This is half. When we chose x to be half. So finally, when we numbers greater than 1, so I got 4 for above. So, and I chose x equal to 2. So x equal to 2. So let's, if here is 2. So remember, this one gave us minus 9. So 4 will be small, this is longer. So 4, let's assume here. So this is 4. So with that, we can join our points. So let's join. This is it. This is it. We are sketching. Okay, let me. This is it. This is it. I'm joining. I will still make it bold. This is it. Remember, it won't cross at 1. So look at our graph. Okay, let me color it. No, should I use white? Which one is? Or should I use green? Okay, let's use red. Let me make it thick. So do you see our graph? As you can see, it crosses at 0, but it touches at 1 and minus 1. So this is our graph. This graph y equal to f or h of x. So we sketch, this is h of x equal to half x times x minus 1 squared times x plus 1 squared. So we've sketched the graph. So it's very, very tricky. But once you apply what we've learned, you can sketch any graph, polynomial graph.